AI didn't start with ChatGPT or self-driving cars. It started with something much simpler and, honestly, kind of boring. If-then rules. But those early steps laid the foundation for everything we see today. And if you really want to understand where AI is going, you have to understand how we got here, stage by stage. Let's break it down. Stage 1. Rules-based systems. Back in the 1950s and 60s, the dream of building a thinking machine was already alive. Researchers weren't training models on billions of data points, they were writing rules. Literally lines of code that said, if X happens, do Y. One of the most famous early programs was ELIZA, created in 1966 by Joseph Weizenbaum at MIT. ELIZA mimicked a psychotherapist by rephrasing user input as questions. If you typed, "I'm feeling sad," ELIZA might reply, "Why are you feeling sad?" It wasn't smart. It didn't understand emotions, but it fooled people into thinking it did. That was one of the first real-world moments where humans projected intelligence onto a machine. By the 1980s, these rules-based systems evolved into what were called expert systems. Companies like Digital Equipment Corporation used them to troubleshoot hardware. Medical expert systems like Mycin were built to suggest treatments for infections. For a while, businesses believed expert systems were the future. In fact, by the mid-80s, the market for expert systems was valued in the billions. But here's the catch. These systems were brittle. If you gave them a situation outside their rules, they broke. Imagine trying to write down every possible medical scenario or troubleshooting step. It just didn't scale. That's why expert systems peaked in the late 80s and collapsed by the early 90s. What replaced them was something much more powerful. Machines that didn't just follow rules, but actually learned patterns from data. Stage 2. Machine learning emerges. This is where AI took a sharp turn. Instead of telling the computer exactly what to do, researchers started teaching it how to learn from examples. By the 1990s, machine learning became the dominant approach. A classic example, spam filters. Instead of writing endless rules like, if the email contains the word lottery, mark it as spam, machine learning algorithms looked at thousands of real emails and figured out the statistical patterns that separated spam from legitimate mail. This was a huge leap, because the system could adapt as spammers changed tactics. Recommendation engines also came out of this era. When Amazon introduced its customers who bought this also bought feature in the late 90s, it wasn't random. It was powered by collaborative filtering, a machine learning technique that studied user behavior to predict what else you might like. That recommendation system is still a cornerstone of Amazon's business today. Around the same time, speech recognition started making progress. In 1997, Dragon Naturally Speaking launched as the first large vocabulary continuous speech recognition software for consumers. It required training, but it was a glimpse of what was possible when you combine machine learning with computing power. The limitation, though, was scale. These early models couldn't handle massive amounts of data. They were narrow, good at one task, bad at everything else. But they opened the door to the next stage, when data, algorithms, and computing power collided and pushed AI into territory no one thought possible. Stage 3. Deep learning revolution. If machine learning was about teaching computers to learn from data, deep learning was about giving them a brain-like architecture to learn at scale. The term deep comes from deep neural networks, layers upon layers of artificial neurons that process data in stages. The breakthrough moment came in 2012. A team led by Geoffrey Hinton at the University of Toronto entered the ImageNet competition, a massive challenge to classify images into categories. Their deep neural network crushed the competition, cutting error rates by more than 40%. That single win is often marked as the birth of modern deep learning. Suddenly, AI wasn't just recognizing patterns in spreadsheets. It was identifying cats in YouTube videos. In fact, in 2012, Google trained a neural network on 10 million random YouTube thumbnails. And without any labels, the system learned to recognize cats on its own. That was a moment of cultural buzz. The idea that machines could teach themselves concepts humans never explicitly programmed. From there, the dominoes started falling. Speech recognition systems like Siri and Google Voice went from frustrating to actually usable around 2014 to 2016 because of deep learning. Translation took off with Google Translate's Neural Machine Translation update in 2016, which made translations far more fluent. Then came AlphaGo in 2016. Built by DeepMind, it defeated world champion Lee Sedol in the ancient game of Go, a game considered far too complex for brute force computing. That wasn't just a win in a board game. It showed that AI could master strategic reasoning and long-term planning in ways most researchers didn't expect to see so soon. The 2010s were the decade of deep learning dominance, but deep learning still had one catch. It was narrow. These systems were incredibly strong in their own lanes: chess, Go, image recognition, speech, but they didn't generalize. They couldn't step outside their trained domain. That set the stage for what came next: foundation models that could learn once and apply across countless tasks. Stage 4: generative AI and foundation models. Around 2018, AI entered a new stage, one that directly shapes our daily lives today. Instead of training a separate system for every single task, researchers built foundation models, huge neural networks trained on vast amounts of general data, from books to websites to images. The results were startling. In 2019, OpenAI released GPT-2, a model that could generate paragraphs of text that sounded coherent. By 2020, GPT-3 pushed this to the extreme with 175 billion parameters, showing a single model could handle translation, summarization, Q&A, and even code writing. It wasn't perfect, but it was versatile, a major leap from narrow AI. It wasn't just text. Generative AI spread across modalities. DALL-E 2021 could generate images from prompts. Stable Diffusion 2022 made AI art open source, sparking a wave of creativity and controversy. Midjourney became a cultural phenomenon, with AI-generated art flooding social media. In parallel, text-to-video and text-to-audio models emerged. In 2023, Runway Gen 2 and Pika Labs showed AI could generate short video clips from text. OpenAI released Whisper in 2022, a state-of-the-art speech recognition model, and in 2024 unveiled Sora, demonstrating realistic, long-form AI video generation. By 2023 and 2024, generative AI wasn't just an experiment. It was integrated into mainstream tools. Microsoft embedded GPT into Office as Copilot. Google launched Gemini to compete head-to-head. Adobe added Firefly AI directly into Photoshop. Millions of people now use generative AI every day, from writing emails to creating art. But here's the hook. These models don't understand the world. They predict patterns based on training data. That's why they sometimes hallucinate facts or make reasoning errors. They're powerful, but they're not yet general intelligence. The leap from generating to acting, from responding to initiating, is what defines the next stage: autonomous agents. Step 5: autonomous agents. If generative AI was about producing text, images, and videos on demand, autonomous agents are about taking action. These systems don't just answer prompts. They plan, decide, and execute tasks across multiple steps. In 2023, tools like AutoGPT and Baby AGI grabbed headlines. They chained together multiple uses of large language models to set goals and carry them out with little human input. For example, AutoGPT could be told, research the best headphones under $200 and compile them into a report. And it would run web searches, analyze results, and generate a document. More recently, companies have pushed this idea further. In 2024, Cognition AI unveiled Devin, marketed as the first AI software engineer. Devin could take a high-level instruction like build a site with a logon system and handle the coding, debugging, and deployment steps. While not flawless, it highlighted how agents move us from assistants that help to systems that work. We're also seeing agents deployed in customer service, finance, and even robotics. Autonomous AI call center agents are already being piloted by startups and enterprise firms to handle real customer interactions without human handoff. In robotics, labs are experimenting with giving language models control over real-world robots, connecting reasoning with physical action. But this autonomy raises new challenges. Who's accountable if an agent makes a bad decision? How do we keep them aligned with human intent? These questions tie directly to the next stage in the evolution of AI. Stage 6. Artificial General Intelligence, AGI. AGI is the point where AI systems can perform a wide range of intellectual tasks at human level or beyond. Unlike narrow AI, good at one task, AGI would be flexible, adaptive, and capable of transferring knowledge across domains. Tech leaders openly debate how close we are. Sam Altman of OpenAI has said AGI could arrive within the next decade, while others argue today's large models are still missing core ingredients like reasoning and true understanding. Geoffrey Hinton, one of the godfathers of AI, left Google in 2023 partly to speak freely about the risks of advanced AI, warning that systems may learn faster than expected. We're seeing steps in that direction with multimodal models, AI that can process text, images, audio, and video together. Google's Gemini and OpenAI's GPT-5 demos in 2024 highlighted reasoning across multiple formats. But whether scaling these models leads directly to AGI or whether new breakthroughs are required remains an open question. For now, AGI is still a research goal, not a present reality. But what lies beyond AGI is even more transformative and more controversial. Stage 7. Artificial Superintelligence, ASI. ASI is the hypothetical stage where AI surpasses human intelligence in every domain. If AGI is human level, ASI is beyond human. It could solve problems humans can't, from drug discovery to climate modeling, at speeds we can't match. This isn't science fiction, it's a logical extrapolation. If machines reach human-level intelligence and they can self-improve, they may rapidly surpass us. That's why governments and companies are already talking about guardrails. In 2023, the US and EU began drafting AI governance frameworks. By 2024, over 20 countries signed agreements focused on AI safety and transparency. The opportunity is enormous, but so are the risks. Researchers discuss alignment, the challenge of making sure AI goals stay compatible with human goals. This is one of the most active areas of AI research today. So if we step back, the path becomes clear. We started with rules-based systems in the 1960s, moved into machine learning in the 1990s, hit the deep learning revolution in the 2010s, shifted to generative AI and foundation models in the 2020s. Now we're entering the world of autonomous agents, with AGI on the horizon and ASI as a possible future. Each stage didn't erase the last. It built on it. The brittle rules of the 60s taught us structure. Machine learning gave us adaptability. Deep learning gave us scale. Generative AI gave us creativity. And agents are giving us autonomy. The question isn't whether AI will keep evolving, it's how fast and in what direction. Because if history tells us anything, it's that the next leap often comes sooner than anyone expects. If you've made it this far, let us know what you think in the comment section below. For more interesting topics, make sure you watch the recommended video that you see on the screen right now. Thanks for watching.